Jegadeeshwari, Assistant Professor from the Department of ECE. I am going to take the topic semiconductor, the basics of semiconductor. So semiconductor is nothing but a material with electrical properties. The resistivity lies between the conductors and the insulators. And it also has the property of negative temperature coefficient. It means that the resistivity increases with respect to the temperature decreases. So this is one of the property of a semiconductor material. Another one is the conductivity depends on the impurities which is added to the semiconductor. So these are all some of the properties of semiconductor. And the semiconductor is classified into two types. One is intrinsic semiconductor and another one is extrinsic semiconductor. So intrinsic semiconductor is nothing but it is solely created by the agitation of thermal agitation, created based on the thermal agitations. And in intrinsic semiconductor, the number of holes is always equivalent to the number of electrons. Another one is the temperature also. At room temperature, the conductivity is very less. So these are all some of the properties of intrinsic semiconductor. If we move on to the next, extrinsic semiconductor, it is classified in extrinsic semiconductor is nothing but a impure semiconductor. It is classified into two types. One is P-type semiconductor and another one is N-type semiconductor. So this P-type and N-type is nothing but adding of impurities. It means doping. Doping is nothing but adding of impurities to a pure semiconductor is called doping. So based on the impurities, whether it is a pentavalent impurity, when the pentavalent impurity is added to the pure semiconductor, then we can able to form the P-type semiconductor can be formed. If trivalent impurities, that means that trivalent is nothing but the outermost shell has the trivalent electrons, then if it is added to the pure semiconductor, then we can get the N-type semiconductor can be formed. How P and N-type semiconductors are formed? First we will start with the P-type semiconductor. So we are adding impurities to a pure semiconductor to get the P-type semiconductor or N-type semiconductor. So let's take P-type semiconductor first. Here the outermost, what all the element which comprises the outermost orbit has 3 electrons that comes under trivalent impurities. So we are adding this, for example, boron, aluminum, gallium. These are all the the outermost orbit has trivalent elements. So boron, for example, if we are taking the boron, here the holes are the outermost orbit comprises of 3 electrons. Here the silicon has semiconductor material. For example, silicon and germanium, their outermost orbit will be a 4 electrons. So when we are this is the bond, we are all bonded together. We are adding this impure semiconductor, that means boron with a pure semiconductor silicon. So if we are infused with boron and silicon, there will be a free hole will be created at the 4th one. Okay, likewise, if you are adding numerous doping, if it is added means holes will be, the number of holes will be more in the P-type semiconductor. Okay, so likewise P-type, so number of holes will be there. So here this is called as acceptor atom, adding of impurities in the trivalent impurity. So that is called as acceptor atom. Next we will move on to the N-type semiconductor. How N-type semiconductors are formed? Here we are adding the N-type, that is semiconductor, pure semiconductor, which has 4 electrons in this outermost orbit, is added to the element which has 5 electrons in its outermost orbit. So for example, phosphorus, arsenic, these are all the element which has 5 electrons in their outermost orbit. So if you are adding this means there the one will be 1 electron. These are all bonded with the covalent bonds. So remaining all this will be added together and one electron will be remaining in the semiconductors places. So number of holes will be more in the N-type semiconductor. So here you can came to see that in the N-type semiconductor electrons are the majority carriers and in the P-type semiconductor holes are the majority carriers. Next, how PN junction diodes are formed. So previously we have discussed about the P-type type semiconductor and how N type semiconductors are formed. Now we are going to fuse these P type and N type semiconductor to form the PN junction diode. So PN junction diode is nothing but we are adding that fusing P type and N type semiconductor material together to form a junction. Okay, so in that junction, this junction is called as depletion layer, where the width of this depletion layer decides whether the conduction will take place or not. If it is increases, the depletion layer, width of the depletion layer increases, the conduction between the P type and N type will be less, so there will not be any conduction occurs. So if the depletion layer, the width of this depletion layer decreases, means the conduction will be more. So how it is can be found out? How in PN junction diode, it has to, we have biasing has to be taken place. So first one is it is divided into two methods. One is forward bias and another one is reverse biasing. So forward bias means is nothing but an applied voltage, a positive supply voltage is given to the P type semiconductor. So here in P type semiconductor, holes are the majority carriers. So when we are passing the positive voltage, that is forward bias, positive voltage is given to this P type semiconductor, then these two will repel together, so it will be moved towards this region. It will be attracted towards the N region. So the conduction will be takes place from P region to N region. It will break this region. The width of the depletion layer will be less. So the conduction will be this depletion layer will be very less for the smooth conduction of the PN junction diode. So it will be crossed towards this and the conduction takes place in the forward bias. So reversely, if you are moving on with the reverse process, for reverse process, nothing but if you are giving the reverse bias, in the reverse bias, the conduction will be takes place likewise, like this negative supply voltage is given to positive and positive voltage is given to the negative. So this condition is called as reverse bias condition. Here you can able to see, here everything is attracted. Here P type material, holes are the majority carriers and N type material, electrons are the majority carriers. So you can able to see that if we are giving this negative supply voltage, so if you are giving me, it will be attracted, positive voltages are attracted towards this negative region. So the width of this depletion region will be wider in the reverse bias condition. So this will be a very wider and the conduction will be does not takes place in the reverse bias condition. So this is the thing how the PN junction diodes are formed. And this one is a symbol of PN junction diode. It has anode, one is anode and it has cathode. Two terminal diode is nothing but a two terminal device. It has anode and cathode. Next, in the diodes, the potential difference created by the electric field can be calculated with the help of this formula. E0 is equal to Vt natural logarithmic of Nd Na divided by Ni square. From this we can able to calculate the potential difference across the PN junction diode. So where E0 is nothing but a junction voltage at no bias and Vt is the thermal voltage at room temperature. It may be approximately 26 millivolt and Nd and Na is nothing but a concentration of impurities of donor and acceptors. Acceptors concentration of impurities and Ni is the intrinsic concentration. So this is the formula to calculate the potential difference across created by the electric field across the PN junction diode. So similarly, we can able to calculate drift current, diffusion current, and the knee voltage as well as reverse bias voltage can be calculated with the help of these formulas. Okay. Next, we will have the VI characteristics of PN junction diode. VI characteristics is nothing but the graphical representation between the voltage and the current. For forward bias as well as reverse bias, we can able to create, and you can be able to understand clearly with the help of this VA characteristics. Next one is the VA characteristics of a PN junction diode. It's nothing but the graph drawn between the forward region as well as for the reverse region. So voltage, between the voltage, what is the calculation or characteristics between voltage and the current? In the forward region, you can able to see that the current, initially the current will increases slowly, and suddenly the current gradually increases. So at this region is called as V voltage, where the current increases suddenly. That means it means that the conduction takes place in the forward region. Okay, so knee voltage, the voltage for germanium it's a 0.33 volt. At 0.3 volt, the knee voltage increases suddenly. For silicon, it will be 0.7 volt. So this is the graphical representation for forward region of a PN junction diode. When we move on to the reverse bias, with the reverse bias, here the current will be, and there will be a conduction in the reverse bias also. But the reverse current will be that is called as leakage current. Even though that we couldn't stop the depletion layer, we couldn't stop the conduction or movement of electrons or holes from P region to N region in the reverse bias condition. There some amount of leakage current will be moved towards this region. So at one point, that means that breakdown voltage, that is called the breakdown voltage, there the conduction will suddenly increases. There also, that is called, this region is called as breakdown voltage. So the reverse bias of a PN junction diode, we can able to get the leakage current at one particular point, the current suddenly decreases. So this is called, that region, that voltage is called as breakdown voltage. Next, the properties. So properties of a PN junction is nothing but where we are going to use now. It can be able to rectify the devices. It can able to rectify, as well as it can create a potential barrier between the devices, between the two carriers. It can able to create a barrier, potential barriers, and also it will transform a light energy into an electrical energy. It has the capability of converting a light energy into a electrical energy, and it also radiates some amount of energy which is through which current flows through it. These are all some of the properties of a PN junction diode. So where it is going to apply? So some of the applications of your PN junction diode is nothing but it will acts as a voltage doubler and quadruple in a voltage multiplier. So this is the some of the application of PN junction diode, and it also rectifies. It acts as a rectifier. It means that a conversion of AC to DC, the conversion of AC to DC process, it will convert. It acts as a rectifier in the voltage controlled devices, and it in a photodiode, maybe also it acts as a photodiode. That means light, compares with light photodiodes, and it also employed in solar cells also. Solar cells formation or solar plate formation also. This PN junction diodes are commonly used, and it acts as a demodulators or directors in the modulation process. In the communication system, here it acts as a director to demodulate the modulated signals. So in the receiver section, for PN junction diode plays vital role in the direction of the signals. Communication signals can be directed with help of this PN junction diode. So this is the overall overview of. We'll complete the topic with the overview. Here we have discussed about the semiconductor basics. There, what is meant by semiconductor and how the semiconductors are created and formed, and what are the classifications of a semiconductor, what is meant by how it is classified, whether it is extrinsic and intrinsic and p-type semiconductor, how p-type semiconductors are formed, n-type semiconductors. Then we move on to the PN junction diode, how the diodes are formed. It's a two-terminal device which has anodes and cathodes, where we can able to create, where we can able to form the diodes. So how the diodes are formed, how the VA characteristics of diodes has been explained, and its applications and properties has been discussed. Thank you.